If a successful candidate does not meet the guidelines, another candidate will be chosen. Nomination packages are available in the office and accessible electronically in grade 12. It will also be easier for the senior announcements and for the grade 12 teachers. Please complete it by April 2nd and bring it to the office by 3:05 p.m. Copy bottle drive. If any water bottles, sodas, or cans at home, coffee is using a bottle drive and please drop them off in the donation box. All deposits go towards water and walking. Work opportunity is available or lobby at the Open Public Library. We need volunteers at the Open Public Library. Volunteers will use to learn we provide community patterns. There are 4 days at 2 different libraries.
How's your book in better condition of mine is that? You just stick that in your thing. Stick that in your backpack. Okay.
Come by the Trinity Center for application. Deadline to apply is April 7th. Have a magical Monday.
Okay, is there anyone who's writing the quiz today? Quiz? Yes, okay. Could you go sit over there? Anyone else? Quiz? Okay, so on our list for questions to go over from the review, and yes, you'll be getting your quiz back, just not until we've gone over the review. We're looking at number 5, 25, 33, and 46. Are there any others? Yes. Never mind. You'll come back to it later. Cool. So let's start with number 5. And I'm actually going to write those down somewhere else because otherwise I'm going to lose track of that. 5, 25. So here we have an equilibrium system, and we are given its KEQ. And if we were to write the KEQ expression for that, this is our forward, that would be like that. And if we were to do the reverse, our reverse, yes. Where did I put it? Oh, right here. Thank you. Because we want the equilibrium constant for the reverse reaction, and so our KEQ for that is O2 over NO squared. How does our forward KEQ relate to our reverse? Yeah, exactly. So if you're finding the reverse, it's going to be 1 over. Yeah. So your answer here will be 1 over 3.4 times 10 to the minus 3, whatever that happens to give you. C, perfect. There we go. Yeah?
Yeah.
Cool. Yes. Yes, here's our forward. You get, okay. Yeah. Okay, cool.
Also, KEQ would be like flipped around if it's in the reverse.
Yes.
Oh.
Yeah. Okay. Yeah. Anyone else need to look at it for another minute to get that? Oh yeah, a moment. So this is our forward KEQ, this is our reverse KEQ. They are reciprocals of one another. So if you want to find KEQ of the reverse reaction, you would take 1 over the KEQ of the forward reaction because they are reciprocals of one another. Is good? Cool. Number 25. Consider the following system at equilibrium. Which of the following chemicals, when added, would result in a decrease in H2? H2 is here, so we need to shift left. But watch out, because you cannot add H2 and get a decrease in H2, because if you were to increase concentration of H2, it would still end up higher than it was before. So we cannot add H2 to get it to shift to the left. We could add CO, that would do it. If we were to add CH4, that would shift us to the products, and that would be the reverse of what we wanted, because we want to decrease H2. Adding CH4 would cause H2 to increase. Adding water would cause a shift to the right, which would cause H2 to increase. So the only answer is B. Ronya, you look puzzled. Are you okay? Okay, cool. You just had a look like that, but you're just thinking. Okay, cool. 33. Consider the following system. Which of the following chemicals would result in a decrease in CrO4 2-? So in order to decrease, which way do we need to shift? If we shift to the left, that's going to make more CrO2. So we need to shift to the right. Yeah, so we could add H+, which would cause a shift to the right. Is good?
But
Because
where NO3 is that gonna go?
what's that?
But where is NO3 that's gonna go?
Spectator. It just hangs out, does nothing. Yeah. Just a little note. Don't forget, what if we wanted to increase CrO4? Which of the following would do that? Would D increase CrO4? Yeah, it would, because you would, if you increase Cr2O7, that would shift it to the left, which would make more chromate. What about if we added CrO4? Would that cause an increase in CrO4? If we have CrO4 and we add some, it ends up higher than it used to be. So if we were looking at the other one, then this would also work. How about an AOH? Well, we're wanting to increase CrO4.
Oh no.
This is a hypothetical new question, okay? We're saying what if this question asked about increasing CrO4? How does NaOH increase the concentration of CrO4? has oxygen. What type of substance is NaOH? What type of chemical? Base. What do bases react with? What do acids have? What? Hydrogen. So what would happen if you put hydroxide with hydrogen? You would get water. If that's the case, what would happen to the concentration of hydrogen? If hydrogen reacts with hydroxide, what happens to the concentration of hydrogen? It decreases because you've used up some of it, yes? And if it decreases, which way would this shift? It would shift to the left. And what would that make? It would make CrO4. If we shift to the left, we make more hydrogen and we make CrO4. So in our hypothetical question, yes, this would increase CrO4. Okay? You okay, Romina? Okay. Just thought it was look. Okay. 46. We have an equilibrium and we add some FeNO33 is added to KSCN. Which one of the following statements describes the changes in the forward and reverse reaction rates as the reaction moves towards equilibrium? Well, what's the important ion in FeNO33? There's two ions there. Are they both important or is only one of them important? Only one. The Fe3+. What's the NO3 doing? NO3 is a spectator. In our KSCN, again, we have two ions. Are both of them important or is only one of them important? The SCN is important. What's the K doing? It's just a spectator. So we are starting with some Fe3+. We are starting with some SCN minus. How much of the SCN do we have at the start? 0. Whoops, that was supposed to be a line, not a squiggle. So, what's going to happen? What's our forward rate like at the start? Forward rate is high. Our reverse rate is 0. And what do those two rates do? So, as the reaction moves towards equilibrium, the forward rate decreases and the reverse rate increases. Yes? No, no, we're starting with 0, FESCN.
Um,
It's all like crammed together.
okay.
Yeah, yeah? Yep, good question. That's our 4 questions. Anyone else got anything else? 48? 43? A car's engine has the follow endothermic reaction. So I'm going to put my heat term in there just in case. At room temperature, KEQ is 4.8 times 10 to the negative 31. That's really small. At high temperatures, found in a car's engine, compared with room temperature, would concentration of NO increase or decrease? So at room temperature, we've got this. And then at high temperature, compared with room temperature, what would happen to concentration of NO? It would increase because the system would shift to the right. And KEQ, because KEQ does change with temperature, we're going to end up with more product and less reactant. So KEQ is going to get bigger. So both of them will increase. Is good? We're absorbing the extra heat. That's what the forward direction does. Yeah. Yeah. Anything else? Yes. How 46 works. Okay. So we have some iron nitrate, which gives us iron 3+, and we don't care about the NO3, it's a spectator. We have some KSCN. We only care about the SCN minus, and the K is a spectator. Those two ions come together and they form a compound ion, which is like FeSCN all together, and we haven't put any of that into the beaker, so we got none of that. So we have all reactant, we have some reactant, and we have no product. And if that's the case, then our forward reaction is high, our reverse rate is low, and then this one has to decrease and that one has to increase. Yeah, no problem. I love it when people ask for clarification about something they didn't understand, even when it's been explained, because then we can get to the root of the problem. Thank you. I will tell you that numerous years ago, I had 2 students, and I would say that probably at best, naturally, they were C+ students, okay? At best, because they had no idea what was going on. They were very, very confused a lot of the time. They asked every question under the book. Under the stars, they asked every question. They did all the practice, and every time they did not understand something, they asked a question about it. They both got over 90%. So how much work you put in, how many questions you ask, that's what's going to get you there. And I've had 2 people ask me questions in this class. No, sorry, 3. 3 people ask me questions in this class so far. So I expect they will probably do great. And I don't know about the rest of you. We'll see. Yes. 10, yes. Number 10. Initially, we have 2.10 no, sorry, 2.12 molar CO, and we have 1.10 molar O2. And at equilibrium, ooh, I'm going to need a rice table here. Ay, ay, ay. Okay, I'm going to redraw this over here so I can actually do a rice table. 2CO, whoops, plus O2, 2CO2. So we have an initial concentration, That does not look like 1.10. Let's rewrite that. And we have an equilibrium concentration. What is the initial concentration of CO2? 0. If you're not mentioned, if something is not mentioned in the initial part, or it's not said it's placed in there, its initial concentration is always 0. Okay? And so this is going to now, which way does it have to shift? Has to shift to the right. I had several people on the quiz doing a Q for this, and you don't need to do a Q. If one side is at 0, it has to shift that way, so there's no need for a Q. Not that you can't do a Q, it's just you're going to end up with Q equaling 0. So obviously it has to shift that way. Hi, go away. Now, because we got a 2 here, that's got to be 2x, so this here is going to be minus 2x, and this is going to be minus x. All right, except for that, I don't really need to use x's because I have real numbers. So why am I using x's? Silly me. I always tell people don't use x's if you have real numbers. So 2.02, this one's going to be 2.02 because it also has a 2, same coefficient. And then this one's going to be minus 1.01. So that's going to be 0.09, and that's going to be 0.10. And we will then end up with 2.02 squared over 0.1 squared over 0.09 squared.
For the rice table, we don't need to write units.
No, because you'll be putting them into a KEQ, and KEQ doesn't have units. Huh? No. Yes. Units in a KEQ loses a half, yeah. Well, I mean, in the final answer. Yeah. Well, that's none of the answers. What the heck? I must have pressed something wrong. 2.02 squared divided by 0.1 squared divided by 0.09. Ah, that's better. 4.53 times 10 to the 3. There we go. Are we good with that? You don't have to show the rice table. If you can do all that in your head, that's great. But obviously I couldn't do it in my head. I'd like to see it. On this test, if you find that you need a piece of scrap paper, please ask for one, but I will ask you to attach it to your paper afterwards so that you don't walk out with it. Yes. 58, absolutely. Okay, so we have equal moles of I2 and Br2 are placed into a closed container and are allowed to establish the following equilibrium. I2, Br2, 2Br. I'm going to do a quick little rice table because at least it'll allow me to see what the heck is going on. And I start with equal moles of I2 and Br2. So I'm going to call that X and I'm going to call that X, and I have nothing there. No, I'm not going to call those X because that's confusing. I'm going to call them Y and Y. Y and Y. Now what's going to happen? Yes. Oh, 2IBR. Thank you, thank you. Okay, there we go. That looks better. And this is going to go up by 2X. This is going to go down by X. This is going to go down by X. Now, is I2 going to be equal to IBR? No, that's just silly. Yes? What I do know is that I have actually, you know what? I don't even need this. All I need to know is that I have at equilibrium IBR squared over, and it doesn't seem to care about my BR2. The only thing I need to know here is that BR2 and I2 are the same. So I could actually replace, if I have my KEQ is equal to BR2 times I2, I could just as easily say IBR squared over I2 squared, because BR and I2 are the same. Did you catch that? Oh my God. You catch it? Did you catch that? I haven't answered it yet. So what we've got is we've got I2 and BR2, and we've got KEQ, which is 280. Yes? And so if we take the square root of everything, I don't know what the square root of 280 is. 16.7 equals IBR over I2. So how do these two relate to one another? Well, 16.7 times I2 is equal to IBR. And that means that I2 or I2 is equal to IBR over 16.7. Either of those are true. Is that part okay? Okay. So what that means is that I2 is smaller than IBR. Yes. Yeah, you can kind of say 280 is a big number. So my product should be greater than my reactant. Well, it's IBR squared. So we have IBR squared divided by I2 times BR2. They're both squared. Yeah? Which formula? This one here. No. Because what if the KEQ were 0.007? Would it still be that there's more IBR? Okay, you could probably ballpark it without doing all the math around it and say, that's a big KEQ, relatively large, so I'm gonna have more product than reactant. So no, you don't have to do all that math. You can just say KEQ is greater than 1. So I've got more product than reactant because it's a fairly simple equation. Is good? Okay, cool. Yes. 60. One mole. Oh, this is a rice again. Because we have our placed. What is wrong with this pen? Why do none of the pens work? Let's see if I have a working pen here. That one's been plugged in over the weekend. Anytime you have things that are placed in a container, that tells you those are initial conditions. And when you have initial conditions, what will you be using? You have initial conditions. Therefore, you should be using a rice table. Many people did not do that on the test or the quiz. Many people were just like, ah, everything's equilibrium, throw it in, solve. Hey, oops. Yikes. Okay, so at any rate, we have a rice situation, R-I-C-E. We've got CO2 plus H2, CO plus H2O. And, oh, it's in a 2-liter container. So we need to divide everything by 2. So 1 mole of CO2, 1 divided by 2 is 0.5. 2 divided by 2 is 1. We didn't put any of these in the container. And at equilibrium, we have 0.31 divided by 2. Oh no, that's moles per liter. That's not moles. That's not moles. That's moles per liter. So we have CO is 0.31. And we want to know the equilibrium CO2 concentration. All of these are 1 to 1 to 1 to 1. And so if these guys are going up by 0.31, this is going down by 0.31. And that means 5 minus 0.31, 0.19. Excellent. There we go. Yeah. And then if you wanted to, you could take those numbers and find a KEQ from that. Yes. You have a question? 61? Yeah. Under which of the following circumstances may an endothermic reaction take place spontaneously? So we have an endothermic reaction. Which side does enthalpy favor? Which side does minimum enthalpy favor? The heat side. So minimum enthalpy favors reactants. And if we're going to have this proceed spontaneously, we need something to favor the products. which means that entropy must favor the products. And so a solid forming, that doesn't sound good. Solids have low entropy. The system goes to a lower energy state. That's to do with enthalpy, so we don't care. We already know it goes to a higher energy state. The system's entropy is sufficiently increased. Oh, that sounds good, because then we would have maximum entropy over here if entropy is increasing. So there's only really two answers that even talk about entropy, A and C. The other two talk about enthalpy, and we already know what enthalpy is doing, so we can immediately eliminate those. Yeah? How are we feeling about that? 62, yep. Which of the following entropy enthalpy changes accompanies this change? Okay, so did we go from high enthalpy to low enthalpy? Let's graph the potential energy for this. Is this an uphill or a downhill? This is a downhill. So we've had a decrease in enthalpy. So we are looking at either A or D. And we went from a gas to a liquid. What happened to our entropy? Entropy decreased. Because gases are more random than liquids. You can't go by the arrow here. That just means that what is happening, we don't know. This one actually should be an equilibrium arrow. Yeah. I'm gonna come closer. $16. Which of the following statements indicates that the products are favored? So if the products are favored, what that means is that the concentration of products are high at equilibrium. And if the concentration of the products are high at equilibrium, that means KEQ is large. So our equilibrium concentration constant, is large. Yeah? 73, yes. A gaseous equilibrium system is held in a closed 2-liter container. We increase the concentration of the products. So if we have reactants and we have products, and we increase the concentration of the products, that causes a shift to the left. And the concentration of the reactants will increase. We're making reactants. If we're going this way, we're taking products and we're making reactants.
Yeah, but like, was there something actually at the equilibrium where products were introduced?
Yes, we have a gaseous equilibrium system.
So there were actually reactants.
Yes, there's both things because we were at equilibrium. It says an equilibrium system. Yeah. Hi. Oh, maybe.
Casually asked for 15 meters. That's nothing. What are you gonna use that for? Polygraph.
Did any of you guys ever watch Sesame Street?
Yes.
Would you like to buy an O? Have you ever heard that one? No, you have no idea what I'm talking about. Okay, I'm not going to reference it then. Any other questions? $72. The temperature of a given equilibrium system is increased. So temperature is increased at a constant volume. And so our heat term is positive. So we're going to have heat over here. Our 41 kilojoules over there. So if we increase temperature, which way does it shift? It shifts to the right. What does that cause to increase? CO or CO2? If we're shifting to the right, are we increasing CO or CO2? CO. So that would be either A or B. And if we're shifting to the right, we have made more products. Therefore, KEQ has increased. Yes. 66. A flask is initially filled with NH3. So we have some. How much do we have of the reactants initially? None. So if we have a rate diagram, what is our forward rate to start with? Nothing. So our forward is down here. And our reverse rate is something. And so as they come to equilibrium, our reverse rate will decrease. And our forward rate will increase. So the rate of the forward reaction increases as the rate of the reverse reaction decreases. Yes. 56. And I'd like everyone to say thank you to Noah, who is asking all the questions for you. Okay. Which of the following, when added to the above equilibrium system, would result in a shift to the right? So how are we going to get there? Would adding H plus shift us to the right? Yes, because what does H plus react with in this reaction? it reacts with the OH. So you would have H plus OH is H2O, which uses up OH minus, therefore concentration of OH minus decreases, therefore the system shifts right to bring it back up. If we added OH, that would shift it to the left. If we added calcium, that would shift it to the left. And that's a solid, so it would not have any effect on the equilibrium at all. Thank you. Yes. 21? Oh, this is very similar to that other one we did. We have some iron. Remember that NO3 minus is a spectator. We have some SCN minus. The K is a spectator. So we have some, and we have some, and we have none.
We did this already.
Except for that the question was not the same. The equilibrium was the same. So as time goes on, we have to be shifting that away because we have none of the product. So iron has to be being used up, and SCN also has to be being used up, except for it doesn't say anything about SCN. And we are making the iron thiocyanate ionate, FeFCN. So that's going to increase as we shift to the right. Algomas. Anything else? She got more. Yes. 49, 29. An analysis of the equilibrium system shows that the concentration of the reactants are much larger than the concentration of the products. So we have products is small, reactants is big. Which of these would be consistent with that data? So we want to know our KEQ. So it's not going to be 1 because then the two would be relatively equal. Yeah? It's not going to be 25 because that would be like 25 over 1, which would be a bigger number over a smaller number. You cannot have a negative KEQ. No such thing as a negative KEQ. And if we were to take this and simply write it as a fraction, that would be, what, 3,000ths? So that is reflective of what we've got. We've got a lot bigger reactant concentration than we do product. Yeah? Cool. Yes? 90. The direction in which the equilibrium mixture shifts when an equilibrium of the reaction, it shouldn't say of the reaction below, it should say the reaction above, is heated. 6. Oh, yeah. So our heat term is positive. So that means our 30 kilojoules go over here. And so if we heat it, that's going to shift to the right. So that's going to be B towards the, no, to the right is toward the product side. That's A. Yeah? Cool. Anybody else have anything else they want to ask about? If not, I will return your quizzes. You just can't look at it. Okay. All right.
I'll just sit over there. I get my quiz back.
Whoops, cancel. I'm gonna turn this. Oh no. Where are you guys? There you are. Okay. Sanda. Not here. Zoe. Not here. Nicole. Gianna. Not here. Claire. Aaron. Alexander. Romina. Nathan. Jade. Not here. Joshua. Owen. James. Eric. Tree. Chloe. Matthew. Noah.
Yeah, I'll let you know.
Alex. Isabella. Not here. Bella. Not here. Ronia. Maya. Fiona.
I don't get it. Yeah.
I do have an answer key for this. If anybody wants an answer key, I do have an answer key for this. No, you. Fiona? This is the other one.
Yeah, you're supposed to be. Oh, you can't do on the same time. I just did. Yeah. Yeah. All right, let's try to start from. That's it. Oh yeah. Oh yeah. I did. I forgot. I do that. Oh, same thing.
Yes.
So the next block spaces they have
What's wrong? What's wrong?
I can explain it to you if you want.
Wait, is this question just wait? Did I get that part wrong? That means this.
That's wrong.
That's just wrong.
This whole thing is wrong.
Not the whole thing, but that's wrong.
Wait, if that's just wrong, then how did I get the answer correct?
You didn't get the answer.
Oh. Oh, well, like I know. It's only 0.5. I don't get it. Now, like, you know, so is it that's yeah, now we pick 7, but yeah. No, I did. This one, we should have. 13.5. For what? Oh, I know for what. Because I didn't know. I'm not sure like. It doesn't write. I thought that they also just know. They should have but you have you know, like I've done like you should know. I'm not sad. I'm not like I yeah. My number 3 is wrong because I have not known like our business is right our so this one is for KEQ, right? Okay.
Oh my god. No, it's like
Okay, so this is Q.
Yeah. You have to read the questions to figure it out.
No, I mean I can read next week.
Okay.
Should I just do it in there?
Yeah.
Does anyone else have to continue where I left?
Oh, yeah.
Wait, which questions did I do? I did 1 and 2, right?
Hang on a second. Yeah, you did numbers 1 and 2. Where did I put your quiz?
Can I see what I got on 1 and 2?
Hey, I actually did really good. I mean, I was not. Tell me your score first. Being like, I did. Yeah. Well, no, I got 100%. But, yeah. No.
I'm gonna do it for the It's painful. Yeah, I don't know. It's right this second.
Can I ask?
Yeah.
I'm so confused for my
Yeah. Let me grab an answer key for you. Where did I put them? Okay.
Yeah.
I don't need that. I know that.
So showing the work here. It looks like a work. When am I gonna do that? Here you go. Just make sure that data doesn't look up. Okay, okay? There you go.
Oh, okay. Okay. It was pretty good. I think I can really try. You got love with the easiest thing ever. Wait, Matt, where'd you get that? I thought there was only one left.
No, there's like 1,000. I just don't know where I put them.
Wait, you were in that class? I don't even know how.
There you go.
Are we gonna have a review book?
No. Yeah. This is not very good. Let me throw this away so it does not confuse me. In terms
Hello.
you can, but I haven't had to go through it. Well, if you want to. Everything else is in there.
Wait, can we do that?
You can go online. You know how to go online?
Oh, is it on there? Oh, you posted it. Right. Okay, thank you.
Oh, yeah.
Okay, but how much percentage do you think is gonna drop? Oh, it depends what I have right now. Actually. Yeah.